Okay, so now let's talk about graphing a radical function where we don't have the basic graph. What do we do with that? Well, let's say we're asked to sketch the graph h of x, which is the square root of x plus 3. The process that I identified before was, number one, we need to find the domain. All right, so what is our domain in this expression? Well, to find the domain, remember we set the argument, the radicand in this case, greater than or equal to 0, and we find that x is greater than or equal to negative 3. And so our domain is negative 3 off to positive infinity to the right. So that means if we're graphing, our last point to start out here is going to be at negative 3. So, like in our process in the last one, we want to find ordered pairs to plot next. So, let's pick some points. And we know our very first point will be the very end point of our graph. So let's pick negative 3. What's going to happen there? Well, at negative 3, that means we can substitute a negative 3 into this expression. We're going to get the square root of negative 3 plus 3. But that's the square root of 0. And so our result will be 0. Well, how do we know what else to pick? Well, remember that if we're taking square roots, we want to take square roots of perfect squares. Right? So what are some perfect squares? Well, perfect squares include numbers like 1, 4, 9, 16, and so on, right? Only this time, right, it's not as though if we put in 1 under the radical right here that we're going to get 1 plus 3. Well, that might actually end up being a nice perfect square, but what we're going to do is this. If I want to take this, I'm going to take my argument and I'm going to start setting it equal to those perfect squares. So in this case, what happens if I set 1 equal to x plus 3? What value works out there? Well, in this case, if I solve for x, I'm going to get negative 2. And if I put in negative 2 for x, look at what happens. Negative 2 plus 3 is what gives me the square root of 1. And so my output here will be 1. Well, what would you have to add to x? What would you have to add to 3 to get 4? Well, in this case, that's easy also. We just have to add 1. So if we put in 1 for x, we'd be taking the square root of 1 plus 3, which is our square root of 4. And the result of that will be 2. One more. Let's say x plus 3 is equal to 9. What value of x works there? Well, in this case, that has to be 6, because the square root of 6 plus 3 is the square root of 9, and that's 3. So let's see what happens right here. If we do our graph out, that means that if I put in negative 3, I get 0. If I put in negative 2, I get positive 1. If I put in positive 1, I get 2. And if I put in positive 6, I get 3. And now you can kind of get the idea of what the pattern looks like. And if you remember, our square root graph basically looks like the one up here on the screen on the left. And so our square root graph should look very similar, except that it starts at negative 3 instead of 0, 0, and goes off to the right. So h of x has the graph shown here, starting at negative 3, 0, as per our domain, and then going off to the right towards positive infinity. Process isn't too bad. Okay, let's try another one. This time, let's try our cube root one. So let's say this time we're told to sketch the graph y equals x to the 1/3 power plus 3. What do we do with that? Well, again, recall that x to the 1/3 is the cube root of x. And this time we're adding 3 to the outside of that. So our domain, remember to identify the domain first, is going to be the set of all real numbers from negative to positive infinity, right? So the set of all real numbers. Okay, so the second thing is we need to pick some points. Well, this time, because the cube root is under the radical, or x is under the radical, right? We're only taking x this time. What we're going to do is we're going to pick values of x that are perfect cubes. So we want to pick perfect cubes. What are some perfect cubes that we know? Well, we stated it in the last video. And if we're looking for numbers that might be perfect cubes, of course, 0 is a really good candidate because that's an easy one, right? We would be taking y to be equal to 0 to the 1/3 power plus 3. Well, the answer to that is 3. So this graph must pass through the point 0, 3. How about 1? 1 is a perfect cube, right? So if we say 1 to the 1/3 power, we're taking the cube root of 1 and adding 3 to that. So that's going to give us 4. How about negative 1? Well, negative 1 to the 1/3 power added to 3 is exactly the same thing as negative 1 plus 3. That's going to give us 2. All right, this seems weird. Let's try another one. How about 8? 8 to the 1/3 plus 3. Well, we're going to be taking the cube root of 8, so that's 2. Added to 3, that's going to give us 5. And if we put in negative 8, let's see what happens. Negative 8 added to the 1/3 added to 3 is equal to negative 2 plus 3. So that's going to give us 1. Well, these numbers seem kind of strange, but let's try it out right here. So we said at positive 1 we're going to get 4, whereas at negative 1 we're going to get 2. If we put in positive 8 we get 5, and if we put in negative 8 we get positive 1. Well, this almost looks familiar, and if you go back to the shape that we had for our cube root function right here, it looks exactly like that, except perhaps shifted upward. So if we trace our points following that cube root type of pattern, well, there it is, right? It's just the graph of y equals the cube root of x shifted upward by 3. But this is our graph, y equals x to the 1/3 plus 3. Okay, good luck with your graphs and your homework this week. See you in class.